Future class, let's look at these notes on graphs of sine and cosine functions. So there's the different objectives we're going to do here. We're going to look at the graphs of sine and cosine when we got a number multiplied out in front or on the inside or both. And using those forms of the sine and cosine graphs or functions, we're going to determine what's our amplitude, the period, what those ideas mean, and then we're going to use key points to graph them if we were to have to do it by hand, but also how technology can help with that. All right, when we are graphing trig functions, the 6 trig functions, we are thinking of the y-coordinate being a function of the x-coordinate, but the x-coordinate is like an angle inside of the sine and cosine function, and the output is the output of the trig functions. So what I mean by that is the input here is an angle that goes inside the sine function, and the output would be like a y-coordinate on the unit circle. All right, the output here would be an x-coordinate on the unit circle. The output here would be like the tangent. The slope of the line that connects the origin to a point on the unit circle, which is what we think of when we think of the tangent function, or the y-coordinate divided by the x-coordinate at that given angle. But the inputs now are angles, and the output is the sine, cosine, tangent, secant, cosecant, cotangent of the function. All right, let's start off with sine, just a sine x. So there's the sine function. There's another video that I've posted that shows you where all these points come from, but there they are as points. Right, the inputs are those special angles that we see on the unit circle, and the outputs are those values that we see on the unit circle for the y-coordinates on the unit circle. But we're plotting them instead of points on the unit circle as xy pairs, where x is the angle on the unit circle and y is the y-coordinate from the unit circle. All right, we can do this easily with our TI calculators. We're going to type in y equals. I'll clear all this stuff I have in there out. If you have stuff in there, clear them out. Go up to any plots that are turned on, and you know a plot is on if it's darkened in like that, and just hit enter, and it'll turn that plot off. Now it's no longer on. All right, now I'm going to go to y1. I'm going to type in sine x, and x is this button right here, x t theta n. Close that parentheses, and then I'm going to, instead of hitting graph, I'm going to press zoom, and then I'm going to come down here to zoom trig, which is number 7. All right, and then there's what it shows me, and what that is this little wave of the graph is from the origin to the right. All right, this is also showing that starting at the origin going to the left, that same wave. But you can find these points. You can plug in these values. Like I could press, this is, if you look on your calculator right underneath the screen, there's a trace button. I could press trace, and notice it says 0, 0. All right, when x is 0, y is 0. That's that point. If I wrote in pi over 6, pi divided by 6, all right, x is pi over 6, I hit enter. There's that point, pi over 6, 1/2. All right, notice it's given it to me in decimal form. You will not see points on these TI calculators that have pi over 6, pi over 2, 5 pi over 6. You won't see that form here. Okay, so you're gonna need to again either memorize these points from the unit circle, or just know the decimal versions of those points, or just again play around with it and figure out what's what. All right, there's a bunch of properties of the sine function. The domain is a set of all real numbers. That's the idea that because the domain is x and x are angles, and we can just keep going around the unit circle forever and ever and ever, we can just plug in anything into this, and it just keeps on going with that wave pattern forever. All right, -1 to 1 is the range. That's the low point to the high point that we're seeing here, the y-coordinates. It doesn't go above 1. It doesn't go below -1. All right, we have that odd function. So what that means is if, positive pi over 6, positive 1/2 is on this graph, then negative pi over 6, negative 1/2 is on this graph. So if you change the x-coordinate to its opposite, you change the y-coordinate to its opposite, and you'll remain on the graph. Period's 2 pi, that's how long it takes to leave the midline, reach the peak, cross the midline again, reach the bottom, and then come back up to the midline where we started. So that's 2 pi, that's actually -2 pi to 0, so that's 2 pi units. That's 0 to 2 pi, so that's also 2 pi units. That's what, again, it means to be a period. It's not just we get back to where we started. Notice I'm right here, I get back to where I start here. That's not a period. I get back to where I started and I'm in the same direction, meaning I'm rising here. Right here, I'm back to the same y-coordinate, but I'm falling. So that would not be a period. So we get back to where we started, but also moving in the same direction, either going up or going down. X-intercepts are multiples of pi, so 1 times pi, 2 times pi, 3 times pi, 0 times pi, negative 1 times pi, and so on and so on. Any multiples of pi. Right, y-intercept is 0. Again, that's the origin. Graph of the sine function does pass through the origin. Any odd function has to pass through the origin, or any continuous odd function, I should say, that passes that has origin symmetry. Maximum values, minimum values, the positive ones and negative ones, these are the values where you'll see those positive ones occur. These are the values you'll see the negative ones occur. Now, the big thing you're going to get used to in this section, and what makes this section difficult at all, are these transformations of the sine function. So when we multiply the sine function out in front of the function name by a number, we get a vertical stretch or compression. Stretch if it's bigger than 1, compression if it's less than 1, by the amount that's in front, meaning the highest point is 1. If I multiply by 3, the highest point is going to be at 3. So what I'm going to do here is, there is the sine function. I'm going to do y equals, and then right down below it, I'm going to do 3 times the sine function. And when I hit graph, there's the sine function, and now you're getting 3 times that sine function. So you can see it has all the same x-intercepts. So 0 times 3 is still 0. It's just all the other outputs are being multiplied by 3 before they're plotted. So they're always 3 times as big as they were. So the negative 1 multiplied by 3 is negative 3. The positive 1 multiplied by 3 is positive 3. So this thing is being stretched. All right, now the range of 3 sine x is negative 3 to positive 3 versus negative 1 to positive 1. Right, I'm going to turn that one off. You can just go down here, highlight the equal sign, and just press enter, and it will turn the graph off. I'm going to go down to the one below that, and I'm going to put in negative 2 sine 2x. So first of all, I'm going to just do negative 2 sine x, and then we'll do the 2x. So negative 2 sine x. And so what I want you to see here, here's the sine function, and then negative 2 sine x. We'll flip this over to where all the places we had 1, now we're going to be at negative instead of 1, negative 2. And all the places we were at negative 1, now we're at positive 2. So it's flipping it over and stretching it. Now I'm going to briefly turn that one off as well, and I'll build up to that negative 2 sine 2x. Now I want you to see what the sine of 2x looks like. All right, so I just type it in like that, parentheses, not 9, and here is again sine, and here comes sine 2x, and you can see that I'm still going between 0 and 1. It's just I'm doing it quicker, meaning the reason why it's going quicker, or I'm seeing 2 waves for every time I see 1 wave in the original sine, is because we're doubling the input, we're doubling the angle. So if you think about it, if I go around 1 time in between 0 and 2 pi, if I double that angle, I'm now going between 0 and 4 pi. So I'm going around the circle 2 times. And so that wave is, I'm going around the circle. Let me turn this one off. So it was that I was rising to a peak, falling, rising up again, and that was 1 period. Well, now I'm going through that process twice in that same window because I'm going through the circle twice now. All right, we'll turn that one back on, and now I'm going to ultimately alter this one like the slide shows. I'm going to do second insert. Second delete is insert. I'm going to insert the negative 2. So there's negative 2 sine 2x. And what you're going to see now is it's going to make it skinnier. We're going to go through the graph faster, but we're also flipping it over like we saw before. So instead of it rising out of the origin, falling out of the origin, but it's moving again through its cycles faster because we're doubling the input. So now instead of the period being 2 pi for me to go through one, midline to the peak, to the valley, back to the midline. Now we're going midline down to the valley first, then up to the peak, and then back to the midline. And we're doing that all in half the amount of time. So we're doing it in pi radians rather than 2 pi radians. So this one would have a period of pi, where the original had a period of 2 pi. And that's what you're seeing here, okay? That's called a horizontal compression. We squeeze things in. It looks like we're squeezing things in left to right horizontally. It's just the fact that we're making it through the unit circle. Think of it like that. We're making it through faster because we're doubling the input, which again, the input, you can think of the input of a trig function as an angle. So we're doubling the angles. So at 30 degrees, we're now at 60 because we doubled it. So we're making our way through the circle faster. All right, this would be a graph on Desmos showing that technology, going through sine x and negative 2 sine x. Desmos is fine with me if you want to use that for like homework, but just know you are going to need to be able to do it with a TI for your final, for your midterm and final. All right, cosine, the same thing. You saw that video explaining where all these points come from, the cosine function. These are now the x coordinates on the original unit circle. These are the angles. These are the x coordinates at those angles. So now when I go back in here, I'm going to clear out all of this. I go back up, I'm going to put in y1. You can put in any of them. I'm just going to put in y1 is the cosine function. All right, if you're seeing a funny graph, make sure that you look at your mode and that you're not in degree mode. If I was in degree mode, just so you can see it, all I would see is this virtually horizontal line, and it wouldn't, that was not going to look like what I'm getting ready to show you. That's because it's doing degrees, and there's 360 degrees and 1 revolution. And again, with radians, there's 2 pi, pi being 3.14-ish, so 2 pi would be 6.28. So in a span of 6.28 units, we're doing what degrees do in 360. So it's a much different, drastically different scale. So you need to make sure if you're not seeing the right thing, the first thing you should check is your mode. Are you in the radian mode? All right, so now I'm going to graph it. There is the cosine wave. The big difference between the sine wave and the cosine wave is cosine at 0 starts at its peak rather than at the origin. So cosine does not contain the origin where sine does. Okay, so when we need to initially start at the peak or the valley, we could negate this and be down at the bottom, the minimum. But if we need to start at the peak or the bottom, we're going to use the cosine function in our operation, our modeling. All right, same as before, I can press the trace button. Notice it puts me initially at the x equals 0 point, but I could plug in anything. I'm going to plug in pi, so second caret is pi, and hit enter, and you can see that it's putting me at that point. All right, I can also just press trace and just move around on the cursor. I can get all different points, but it's not going to find a lot of the special angles unless you manually type those in. All right, there's the domain and range of the cosine function, very similar to the sine function. It's even, meaning that it has symmetry at the y-axis rather than origin symmetry like the sine function had. Cosine, because again it's the x-coordinates on the unit circle, it has a period of 2 pi, just like the sine function did. Those x-intercepts are the odd multiples of pi over 2. Y-intercept is 1. That means, again, the output when 0 goes in is 1. Right? It has its maximum values occur at multiples of 2 pi, and it has its minimums at the odd multiples of pi. All right, again, when we alter the cosine function, just like when we altered the sine function, same things happen. If I stick a number out front, that's how much those maxes and mins are stretched. So there's 2 cosine x. So it's still starting at the peak, going down and making one cycle through all the y coordinates in a span of 2 pi units. Okay, but now it's going up to 2 and down to negative 2. All right, but again, just like with the sine function, if I stick in, instead of just x, if I stick in, notice this is a 3x. If I put a 3 in there, now it's going to make it through its one cycle around the unit circle in triple, or a third of the amount of the time, or a third of the angles needed, but we're tripling the angle now. So we're going to have much tighter waves because we are going in this screen that would go between 1 revolution around. Now we're going around 3 times. You can see we're going to peak, valley to peak 1 time, valley to peak 2 times, valley to peak 3 times in the same span where the unaltered cosine would have just done it. It's a peak, valley, peak a single time. So again, the number that we put in front of the x is how many periods or how many times we would go through an entire cycle in the same amount of time that we went through one cycle before. All right, if we did something like negative 4 cosine, and if I did something like 1/2, so 0.5x. So watch what happens here. So here's the regular cosine, okay? And you can see I'm going from peak down to the minimum, back up to the peak. If I negate it, instead of the peak occurring at the middle of the graph at 0, now the valley, the low point is occurring at the middle of the graph. All right, and notice instead of making it from peak all the way down to valley back to peak, I go from valley up to peak, but I don't make it all the way through. Again, that's because I'm only doing a half of the amount in here. So this actually kind of stretches it out horizontally. All right, next we want to determine what is the amplitude, what is the distance between the midline and the highest point on the graph. And what's the period? How long does it take it to get through an entire cycle for sine and cosine? Okay, when you see sinusoidal, when you see this word right here, that means sine or cosine graphs. Okay, sinusoidal could be, it sounds like it's just going to be the sine, but it could be sine or cosine. Notice that the sine function is just the cosine function shifted, or I could say the cosine function is the sine function shifted. But this is a way that we can go back and forth between them. It's just this shift between a function and basically pi over 2 units. And that's the cofunction definition, right? That comes from what we saw with the right triangle trig. You know, if I have a triangle, a right triangle, draw that a little better, and this is my angle x. Well, this angle up here would be 90 minus x, or pi over 2 minus x. And the cosine of pi over 2 minus x is the same as the sine of x. All right. Now this is x minus pi over 2, but if you recall that odd property, even property of cosine, if you flip the order, you would just negate the angle, meaning like 90 minus 30 is 60, right? But 30 minus 90 is negative 60. And the cosine of 60 equals the cosine of negative 60 because it's an even function. So this is just the cofunction property here of sine and cosine. That's why it lays down on top of it when we shift it by 90 degrees, or pi over 2 radians. All right, the amplitude. All we mean by the amplitude is the distance from the midline of a sine or cosine wave to its peak, or technically to its valley as well, or you can think of it half the distance from the low point to the high point in a sine wave. All right, and then the period is how long does it take to make a complete wave. For sine, it would be from the midline up to the peak, down to the valley, and then back up to the midline. For cosine, it would be how long does it take to get from the max down to the minimum, back up to the maximum. And it typically is 2 pi, but if there's a number in front of x, then that is dividing that period because it's speeding us up through there. Remember that when we had a 2 there, we were saying we're getting through the wave twice as fast. But that means the period would be 2 pi divided by 2 pi. It would get us through there in pi units rather than 2 pi units. So that's how we calculate the period, is by dividing 2 pi by that number in front of x. All right, let's look at this number, this example of numbers rather than letters. So we got 5 sine 3x. So we want to find the amplitude and the period. Right? The amplitude is the absolute value of the number in front of sine. So the absolute value of 5 is 5. That's our amplitude. All right, the 3 is the number in front of x. So that means we're going to divide 2 pi by 3. So 2 pi over 3 is our period. All right, so let's turn the graph on. All right, there's 5 sine 3x. I'm going to do graph. You can see I'm going out of the window here. So what I'm going to do is I'm going to change the window. I'm going to press window. My min and max are these two numbers that are determined by the fact that I used zoom trig before. I can make my minimum be 0 and make my maximum be what a period is. So I'm going to do 2, so there's 0, enter. Make my maximum be 2 pi over 3. All right, and then my scale, this scale is again determined by the default, or sorry, the zoom trig window. That's just pi over 2 right there. I'm going to make it be pi over 6. All right, and then my y minimum. All right, we said the amplitude is 5, so that means I would need to go down from -5 up to positive 5. All right, my scale is 1s. That means that's going to be every tick mark is 1 on the axis. All right, I'm going to hit graph, and when I do that, now I'm going to get 1 full revolution. So there's my 0 up to the peak, back down to the valley, back to the peak. So there's 1 period of the sine function. And again, my period is 2 pi over 3. So that's what I have on that right edge on my window. And my min and max are the amplitude, right? So again, the 5, I want to make sure you understand that. We're going from 0, the midline, up to 5, 0 down to negative 5. So the total distance that's covered here would be negative 5 to 5. That's 10. Half of that would be 5. So the amplitude is not the distance from the min to max. It's the distance from the middle of the curve, the midline, up to the max and the min. All right, on this part, graphing sinusoids using the key points. The key points that we're referring to here are, if we go 1 period, that's 0 to 2 pi, typically, again, if it's unaltered, both of these functions. Halfway would be pi, right? That would be half a period. And then halfway between those would be pi over 2 and 3 pi over 2. And at those points we hit, for sine, we hit a maximum and a minimum. And then the 0, pi, and 2 pi, we hit x-intercepts. Okay, so that's 5 points. And that's the key points that we're talking about here. They're the I call them QPP, quarter period. All right, and they're the starting point, the full period, half a period, and then those 1/4 and 3/4. Those are the 5 points that you're going to need to be able to alter and figure out where they end up if you're going to do this by hand. All right, always check it with your calculator, but you should be able to come up with where these 5 points go for the first period of a sine function, or cosine. All right, so I'm going to show you how to do it with 2 sine 2x. All right, so here's 2 sine 2x. I'm going to start off with just a horizontal axis, okay? Now, because there is nothing being added or subtracted to the x in here, that means that we're not shifting to the left or to the right, so we're going to be initially at the origin. Okay, so 0, 0 is still going to be the coordinates of that initial point. All right, now the period is altered. There is a number that's being multiplied by the x on the inside. So we would need to divide 2 pi by that number to get the period. So the period here is pi units. So that means we're going to come back 1 full period at pi units. So at pi 0, we're going to be back on the midline. All right, and now you're ready to start doing the halving. So halfway between these two, 0 and pi would be pi over 2. And all I'm doing there is just adding these together. 0 plus pi is pi. Dividing that by 2, pi over 2. So that point right in the dead center is pi over 2, 0. Right? And that also is a midline intercept where we cross, again, in this case, the x-axis. All right, and then we do our quarter period, our 1/4 and 3/4. So at the 1/4 point and the 3/4 point, we're going to hit the max and the min, and it all depends on the sign of this number. All right, if it's positive, we go up first, then come down. If this were negative, we would go down first and hit the minimum, and then go back up. So, but because this is positive, we're going to hit our peak, and then we're going to hit our valley. All right, what's the coordinates of this? Well, it's the average of these two. So again, it's 0 and pi over 2. Add those together, you get pi over 2. Divide by 2, you'd get pi over 4. So this is occurring at pi over 4, but the height is not 0. What's the height? It is determined by the amplitude. So it's the high point. It's typically 1, but because we're doubling it, it's at pi over 2. Pi over 4, sorry, 2. I'm going to put it up here, actually. All right, and then this low point, the same thing. We would average these two. So this is pi over 2 and pi. So that if you add those together, you get 3 pi over 2. Divide that by 2, you get 3 pi over 4. Again, another thing you can do, I've talked about this before, for technology purposes, you can ignore the pi. So instead of pi over 2 plus pi, I would do 1/2 plus 1, hit enter, divide that by 2, all right, and then math into a fraction and then just stick the pi back in there. So this is at 3 pi over 4. And again, because the amplitude is 2, we go down to -2 instead of -1. And so that's where these 5 points would be for this particular graph. I can, again, graph this in the TI calculator, and I'm going to change my window now. 0, I got pi for the period, so I'm going to change the x max to pi. The scale, you can do whatever you want to here. I'm just going to keep it at pi over 6. That's a good scale to use because that puts tick marks at every pi over 6 units, which is going to catch pi over 6, pi over 3, 7 pi over 6. It's going to catch a lot of those points that you would see on the unit circle. So I use pi over 6 for a lot of my scaling if I'm using trig functions. And then my min and max, I'm going up to 2 and down to -2, so I can make my y min be -2 and my y max be 2. All right, and then when I hit graph, I'm going to see this wave that I've got graphed here. All right, so that is the quarter period points method. You can press trace, and you can get these points. So 0, so I get 0, 0. If I plug in pi over 4, again, I just hit second pi over 4. All right, and I see I get 2, which is that peak. It's kind of hidden by the text. All right, I can plug in pi over 2. That's that number in the middle. 3 pi over 4, and you get the idea. I can get all the different key points on here just by using that trace button and verifying that my quarter period points are accurate. All right, they're taking that full period length, and when you're looking at these instructions on the PowerPoint, they're taking that full period length and just dividing it by 4 to get the fact that there's quarter period, 1/4 of a period, and getting the intervals there. So they're just adding pi over 4 over and over and over again to get those quarter period points. And so that's perfectly fine to follow those instructions. I particularly like to use the averaging. Find the starting point, the ending point, the number in the middle, and then divide those in half. That's the method I'd go with, but it's perfectly fine to use the method in the PowerPoint. All right, let's look at this function, 4 sine negative pi over 4x. All right, the first thing I would do before I graph this one is I would use the odd property of the sine function. Take that negative out from the inside there and stick it out in front. Okay, so that's the odd property of the sine function. So what's going to happen now, instead of the sine function rising off its midline like that, because of this negative out front, it's going to initially fall like that. So that's what we're going to be plotting here. All right, because there's nothing being added or subtracted from the x in here, we are going to hit the origin. Right, the period, instead of it being 2 pi, we're going to have to divide by pi over 4. Remember how we multiply, divide into fraction, we multiply by the reciprocal. The pi's are going to cancel. So this has a period of 8 units. All right, so that means that I'm going to get myself back to the midline at 8, 0. All right, so there's the origin at 0, 0. 8, 0, we're going to be all the way back. Halfway between there, we're going to also be at the midline. Right now, because we are falling, again, this negative means we're going to fall first instead of rise. We're going to go down to the minimum and then up to the maximum. All right, this is halfway between 0 and 4, so that'll be at 2. This is halfway between 4 and 8, so that'll be at 6. So there will be our one wave of this altered sine function. All right, I've got it plotted in my y1 on my calculator. I'm going to go to my window. I'm going to make the x min 0. I'm going to make the x max be 8. All right, I'm going to make my scale be 2 because that's what I got for my quarter period point, my quarter of a period. My y min is -4, and my y max should be +4. All right, I'm going to hit graph. So there I fall down to the minimum, rise up to the middle, peak, and then fall back down to the midline. So there is that graph, and that's the same thing that we got there. So again, there's that quarter period point method. If you look at the definitions, what they show you on here, they're going to do that. Find the period, divide that by 4, go up by the quarter of a period to get those 5 points x coordinates, and then just know because we're falling, go down to the negative first. So there's the way they do it. It's very similar to what I'm doing. I'm just doing it by halving rather than coming up with what do I need to add to go from one point to the next. whichever method makes more sense to you is the method you should do. Now, with cosine, the only difference is where we start from. We don't start at the origin anymore. Now we start at either the max if it's a positive cosine or a minimum if it's a negative cosine. All right, so there is my y-axis. So a couple of things that are different than this one than the others. This one has what we call a vertical shift. We are subtracting 2 units. Okay, so what that's going to do is that's going to take our midline being the x-axis to now the midline is down here at -2. So I'm going to draw this little dashed line. I like to draw it as a dashed line, the midline. And instead of us going up and down from the x-axis like we have been on these other pictures that I've drawn, now that line that we go up and down on where these dots are in the middle are going to be occurring at y equals -2. All right, but once we get that taken care of, now we're just focused on this. Okay, so first thing you always do is get your period. So we're going to take the 2 pi, divide it by the number in front of x. The pi's cancel, that just leaves us with a 2. So that's going to be a period of 2 units. So at 2 units, there's 2. I'm going to be either at the max or the min. Again, it depends on the number that's in the front. All right, for cosine, again, it typically starts off at its max and goes down and then back up. But because it's a negative number, it's going to start at its bottom and rise up and then go back down. All right, now it's doing that from the peak and it goes through the midline at those quarter periods, 3/4 of the way. So again, this was the amplitude. So from that -2, we're going to drop down 4 units all the way down to -6. And we're going to add 4 units all the way up to +2. That's where we're going to go down and up from. So again, that's our max and min because of that -2 there. All right, so because it's a negative cosine, we're going to start at our low point. And our low point is going to be down here at -6. Right? Because the period is 2, we're going to end back up at -6. All right, and with the cosine function at the halfway point, like halfway between these two, which will be at +1, we will be at the peak. All right, and then halfway between 0 and 1, halfway between 1 and 2, so 0.5 and 1.5. Those are the midline intercepts, not the x-intercepts, but the midline. So we will cross that line y equals 2 at those points. So it'll look something like that when we graph it. All right, so again, I'm going to go y equals, I'm going to type in everything we see here, -4 cosine pi x, close it off. This is minus this time instead of the negative number. So this for subtraction, this for negative values. All right, I'm going to hit my window button. I'm going between 0 on the x-axis and 2. So 0, 2. I'm going to make my scale be 1. My y minimum is -6. My y maximum is +2. All right, and I'm going to go up in 2s instead of 1s, and then hit graph. All right, so there is one period of this function. All right, now be careful, they may ask for more than one period. If they ever do, you would just add these same units. So this is 0 to 1/2. So I would go from 2 to 1/2, and I'd hit the midline again. And then 1/2 to 1, I'd go up to the peak. So from 2.5 to 3, I'd go up to the peak, and so on. You can make as many of these as you want once you have that first period completed. All right, then the final objective here is the reverse of this. Coming up with an equation when you are given the graph. So if I have a graph and I see the key points like 0, 0, 1, 2, 2, 0, 3, -2, 4, 0, can I come up with an equation that would do that? And the answer is, yeah, we just have to think through it in reverse how we come up with this. So when I'm looking at this, I can see the full period is 4. So I set 2 pi over something is equal to 4, and that something I'm looking for is the number I multiply x by. So doing a little bit of algebra, I can solve for that w and get that number is pi over 2. So that's going to be sine of pi over 2 times x. Right? And then a is how high we go off the midline. So I go up 2, I go down 2, so that means a is 2. So there's my equation that would get me there. All right, I can graph that and verify that I get the correct values.